So I'm going to have a look at the number 10s under a scanning electron microscope, and I will be able to actually see these in a lot more detail and also analyse what the material is on the tips. I can see there's a little space on it, and this is going to appear much larger when I go up in magnification. And so these are the tweezers, right? So I don't know if I'm going to be able to marry up the video of this and the video of what we're seeing in the electron microscope here. This is about 23 times magnification, and as you see, this is my problem. I've got the little gap at the tip between it. Now that might not seem actually that far. If I just grab a ruler here, oops, and just measure it on it, you can see that's about 250 microns, so about 0.25 millimeters. Now again, that might not seem large, but I'm looking to grab something about 50 microns in size. The problem is 50 microns in size is probably going to be around the middle. If I just go up in mag and I just move that, so that's about 50 microns here at this location. So if I just go back to it, that's about here. So if I just measure across, again, apologies if this is a bit hard to see, I might just change the color, check that out, I'll just do that again. So I'm going to measure about here. So that's about 2 millimeters across, or 1.5 millimeters from the tip. And I'm grabbing something that's 50 microns in size and also about 3 millimeters across. So I'm actually gripping not the edge, I'm gripping most towards the half. If I just move a little bit further on, so if I'm grabbing a screw or something, that's probably okay. So maybe it is just that I'm moving it a bit too much here. I probably should, and then here we can see that's the edge of our coating here. So let's actually have a look at it. I'm going to just change it to maybe the backscattered. This allows us to see compositional difference. And so you can see bright area here, dark area here. And so I'm going to check the bright area with the elemental analysis and then the dark area. So I'm just going to switch to there. Oh, let's just remove that. Right. Oh, it's not a best resolution, it's just the way that I'm doing it. But basically this is your iron, chromium, manganese, nickel. There is barium and sulfur. We're gonna go into that in a bit. So let's, I'm just gonna zap different areas. So this is the iron, chromium, manganese area. And there's a tiny bit of nickel gonna just jump up in a minute. I can see the peak, it's just it needs to be identified. Yep, there you go. And if I move over to here, this is the anti-static layer. And you can see that I've got carbon and oxygen present. That's the two little symbols on the left hand side, because obviously it's also getting displayed at the very bottom. Now if I just hit a few different areas, because I did see another peak here. Yeah, see that you've got this thing saying sulfur, and there's a peak just above at about 4.5. Yep, and there's barium, so it's a barium sulfate. Now I should be able to see where these particles are when I actually look at the backscattered. So let's just switch back to here. I'm just gonna move over And let's just increase the mag. And here you go. So these are the particles that belong to the barium sulfate. So I'm just giving this a bit of a focus. Right, and we've also got these dark splodges as well. Now what I might do is I might switch to a low vacuum in a minute to basically remove these very bright areas, and it's because the antistatic is non-conductive, so basically the electrons are getting trapped inside, and that's where you're getting this illumination. But if I just do a slow scan, yeah, see how you've got these very bright areas. So let me just, I'm gonna jump later to the maybe the low vacuum, or I might do it in a different video if people are interested. But you can see that all these little bright particles are your barium sulfate. You've also got these black splodges, which I'm assuming this is carbon oxygen, so I'm assuming this might be just pure carbon. So maybe what I'll do is I will give it a zap, and I will, yep, so let me just jump back to this display so that you guys can see it. So this has got carbon, tiny bit of oxygen. No, I can't see a difference in it, but there is a chemical difference because I can see it in the image. So I would just need to play around with the settings just to actually see it. So what I'm going to do is I'm just going to jump back to my tips again. And let's just have a little see what else we can see about them. So this is your polishing marks from when they've polished it up. You can see it's quite rough, and this is now 500 times magnification here. Let's just give it a bit of a focus. And we can see the surface roughness. So this can be useful for looking at fracture surfaces as well. These are just the grooves. So if I'm looking at it and I'm trying to see what sort of level of polish it is, I'm probably, if I just bring up the display here, that's a 50 micron bar, so that's about 10 microns. So we've also got something there that maybe it was down to a 3 micron polish, but it's very, very rough. So if they had done it, they haven't properly stepped down the polishing steps. If you are interested, what I can do is I can also see about repolishing these to actually see how much better this polish can become. I've got 2 sets of tweezers. I'm not probably going to be using them for anything else. So let's just go up a little bit more in magnification. Alright, and let's just give a bit of focus again. So this mag is 4,000 times. And so I'm just really just having a little look around so you can see that that's flat. Okay, I've got a little splodge. Now this is likely going to be carbon contamination. Yeah, so see how we've got these little particles on it? I think that's likely going to be the same anti-static material that we actually had. So if I just switch to the backscattered, you can see that it's appearing dark. I'm just changing the contrast and brightness. So appearing dark, it's because carbon is a lower atomic number, and the metal is a higher atomic number, so therefore it appears dark, and the metal appears light. So I'm not sure how much more I'm going to tell on it, but it's just I've just seen actually the quality of it. So I will, while I'm actually on this, I will actually go to, sorry, I've just decided to also just have a little look at the surface using the reflected electron. And if I do this, this is very good at picking up the fine surface detail, and so as you can see it's all nicely scratched. I need to come up with a better way to actually share the screen, but I wanted to try out this video in this way first before moving on. But you do see that they do actually sit together. It's just the problem is when I get to the tip, then you can actually see the gap starting to appear. Okay, so the next one that I'm going to have a little look at is the crocodile clips, and that might come out in a different video. So for now, thank you very much for watching as I investigate the Parkside tweezers more. Okay, so I've just popped in the video of the tweezers and I'm just starting the recording there. Hopefully I can match this up. And interestingly, the little clip that I showed that holds the thing in place, which we're seeing here, if I switch it around, you can see it is actually chlorine based. So it's a chlorinated carbon. So I'm just going to run an instant shot on it just so you can see that it's carbon and chlorine. So it's some sort of chlorinated carbon material. Anyway, let's just jump along. I'm going to just zoom out. That was only about 100 times magnification. Only this shows about how used to magnification them up. I'm moving up. I'm moving it up. We'll get to the points in a minute. Right, okay, and here you can see suddenly we're in the metal. Right, and I am actually seeing it's the same composition as before. You can see iron, chromium, manganese. That's not a surprise, but let's actually have a little look. And this is what I wanted in the tweezers. Let's just go to a secondary electron. And let's just up corner brightness. That what we can see is it comes to a point at the edge. Let me just switch this to the backscatter mode just to make it a bit easier to see. And you might not see it there, but here you go. It's nicely down to a point. Very, very dirty, of course. And I would be cleaning these off, but again, I can see these little particles inside, which will probably be that barium sulfate that I was actually seeing before. But notice that there is actually no gap. Now, it doesn't come exactly to a point here. There's a little bit of gap, but to be honest, I probably can still grab at this. So before, I would have had to grab 1.5 millimeters before I could actually grab 50 microns. Let's actually have a little look at this. So let's bring up the ruler. That's my previous measurements. And just bring it up, and so see, even that's 36 microns. So if I just sort of bring it to the edge here, that's only about 70 microns back. So that's a big improvement. So these are actually much nicer, like much nicer things, tweezers to deal with. So I'm going to keep these. I think these were number 4, but I'll definitely use these ones for what I'm aiming for. And at $4.99 for the 10 tweezers, that's actually okay. So I'm going to add this part onto the last video of the tweezers. Okay, so what have I discovered about this? Well, one, that these are too much of a gap at the tip, and if I look at it here, I can sort of see the gap between it, which shows actually how good our eyes are, because our eyes can pick up 0.2 millimeters of space. So I was quite impressed that I was able to detect that, and I was able to detect that these ones, it was number 8, are actually close to a point. I found that that is actually a chlorinated polymer with chlorine present in the carbon. I found out that this has actually got a coating of, or in the coating, it actually includes barium sulfate. And I have actually looked this up, and basically barium sulfate is often added to high density polyethylene to actually enhance the material properties. It could possibly be that this is HDPE then as the coating. But yeah, I may see about polishing these up and have a little look as I polish these up, how we can actually remove the scratches, if people are interested in that. If not, I got other things that I can look at under the microscope, plus I'll have other stuff on this channel as well. So thank you very much for watching, and I'll see you all soon.